building a model, OpenDrift model, ACCIBERG?
I say ACCIBERG.
ACCIBERG, so neither of the two, you say ACCIBERG. All right.
That's the way I call it, but only because I'm the project manager.
Okay, you're the expert. Over to you.
Yeah. Thank you. Lovely to be here. So, yes, ACCIBERG, as you see by the logo, has something to do with bergs, icebergs, but not only, it's also about sea ice. And it's a connection project. It's at the interface between two beautiful services, the climate change service and the marine services. And we were asked to propose an evolution or develop new services that would be for the Arctic. So here you see some sea ice and some icebergs. That's products from the Copernicus Marine Services. And these are the two sort of topics that I will address here. And it's not only one service we put in Edito, it's actually two of them. So we have one software called IceCap that's been developed by the ACCIBERG, so the entrusted entity for the climate change services. And it's about validating sea ice forecast and ensembles of sea ice forecast, meaning that there's uncertainty included in the forecast. Second one, OpenBerg. So it's open software for iceberg drift trajectories, and that's to be called on demand. So OpenBerg can take one iceberg position and then turn it into a trajectory using all of the data that is available from Copernicus Marine Services, and it needs the currents, the waves for the erosion, for the wave motions, and the winds as well, which are not in Copernicus Marine Services. IceCap is...
You can be a little further back from the mic, then it won't pop. That's all right. It's not me who'll tell you off, it's the sound man, trust me.
Sorry for that. So, to the left, you see that what IceCap can provide to you. You can select one region and different sea ice forecasts. So how fast will the ice freeze in the area in a given season? And you can see the errors increase with time, and the small lines are the different ensembles. So you see a bit of what possible outcomes you may have in different realizations of a future. And the implementation, so that's the last slide before I will ask for the technical people to put on a video. IceCap is pulling data from different services, and that's more complicated. You have to use two different credentials. You have to also download terabytes of data to select all the forecasts in the past for a given region. And that's very complex also because of the dependencies, because it builds upon a library on EasyFlow. So there's been two iterations between ACCIBERG and Mercator. I didn't have to put the hands in the dirt. I'm only managing things here. And I estimated, and that's not only the budget, I think that's my recollection of how many emails have been exchanged and how much time, 1 or 2 months of work. And I'm looking at Renaud to sort of have his approval. It's a correct estimate of the work time spent on this. Before, you actually have a little box in Edito. I found it this morning. It's there. I cannot tell you where it is, but it's there with IceCap, where you can actually get the Jupyter notebook to run. For the icebergs, so the OpenDrift, this was much smoother. There's several reasons for that. It was actually the developer, Knut Frode Dagestad from Met Norway, who I asked on 10th of January, can you please try it? We have a meeting coming up, it's urgent. And on 15th of January, I got an email saying, well, I put it on Wikio. I had to Google to find how to do it. But that being done, it was very quick. It took me 45 minutes, and and I could run it on Wikio. So the reason why this is simpler to test is because the software is already pre-designed in, in a very malleable way. It's containerized. It only downloads the smallest possible subset around the position that you're looking at, and so it's fast to test. And then later on, I don't know when that happened, but I guess Renaud again copied and pasted that from Wikio to Edito. And it was, demonstrated at UNOC how to forecast iceberg. He Renaud again, yeah, as I see you here, you should be standing in my place. He added a few goodies like the interaction with the blue, the robot, and the selection of icebergs from the satellite map where you can actually pick on icebergs. So that's that's become much more, say, useful and much more friendly, user-friendly. And I would like actually the video from Renaud. Yes, that's the one.
About the OpenDrift Jupyter Notebook service on Edito Data Lab. You can find this notebook in the Data Lab service catalog, and then we can open it, this book service. Okay, now we have opened this service, and we are going to load the demonstration notebook. Today we are going to see how to track and simulate icebergs Juliet's fate. And we'll start initializing the environment and learn a bit more about Juliet. So Juliet is an iceberg that has been tagged by our colleagues from the NERSC with a GPS. You can see here. And we can see slightly below some nice pictures of it. So now let's learn more about what happened to this iceberg around the 20th of October of this year. So we'll now open the Edito viewer to see the sea iceberg concentration from Sentinel-1 SAR data. And we see that we have quite high concentrations along the Greenland coast. And we are going to overlay the track from Juliet iceberg. We can see it follows this high concentration area along the Greenland coast. And around the 20th, it will be around there. So now, let's load the GPS data from Juliet and start initializing the model. Now we'll add forcing data to the simulation. So wave and current data from the Arctic MFC and winds from the global atmospheric model. Also, we are going to seed around 100 virtual particles representing each different characteristics of the Juliet iceberg. We are doing so because we have uncertainty in how tall above sea level and how deep below sea level the iceberg is, as well as its length and width. So we'll take this into account into the uncertainty of our simulations. So now let's see these vertical particles and start running the simulations. The model is being initialized and the simulations will start. And we'll soon see the different time steps. So the 48 time steps for 48 hours. Simulation has been done, and now we are going to display animation of the output trajectories. Trajectories animation is there, and we can see that from this starting point here, the virtual particles are following the coast within the main current vein and flows to the northwest, and with some being stranded. So now we'll save these outputs to a GeoJSON file, and we'll compare these simulated tracks against the observations we had in the Edito viewer before. So let's go back to the Edito viewer, and we'll import in the viewer. We'll download our data that has been just generated, and we'll load into the viewer the simulated trajectories. And we can see it aligns quite remarkably well against the trajectory of the GPS trajectory of Juliet, as well as the simulations are really within this be this small high concentration iceberg area we have along the western tip of Greenland. So thanks for listening, and I wish you a good meeting.
Yes, I think we still have a last concluding slide after that. Thanks, Renaud. You could recognize his lovely French accent.
We need to wind. Yeah.
So,
Okay.
yes, what next? So we want to have, for the sea ice forecast, systematic evaluation. So that Renaud has a deliverable on the 31st of December to deliver, remind you of that. So the ice cap will be part of the editor, will be tested and have a little how to use it. And then you can select an area, and that's showing the Siberian coast, where some people have made the wrong decisions in the past and have allowed people to navigate, and then they froze 24 ships. So that's a different story. For icebergs, we want also systematic forecasts of all identified icebergs, so we can plot some more detailed risk maps of where in the coming weeks you will be at risk of encountering icebergs. That's not available everywhere today. So today this is mostly, the ice patrol in the US that tells people you're safe here, you're not safe there, based on aerial surveys. But we could do, a bit more with the tools we have today. And that will need, to invoke the software in a very, in large scale, thousands of simulations. So that will be our next step, I believe, after the end of this project. Thanks.
Thank you so very much. Please take a seat. We will